In this topology, we will see how to apply Eigrp, Dynamic Routing Protocol, and then we will see how to configure static routes and make the static route a secondary route. Secondary route or backup route means it works only if Eigrp is not operational. So you see the networks here, and I have 3 networks. So let me start by configuring the IP addresses. I'll go to config here directly. I'll make the GI01000 of the left network, which is, let us give it directly the first IP address, 192.168.10.1. The subnet mask is 128, and that's it. And I'll go and give the serial 010. I'll make it on first, 200.0.0.1. It is /30, so I'll make it 252, and that's it. And also I'll go to this PC and give it the second address in the same LAN, 192.168.10.2, and the subnet mask is going to be 128. The default gateway is going to be 192.168.0.1.10.1. So hopefully this LAN is working fine. Let me just ping and make sure is everything inside the LAN is working fine. 192.168.10.1. Excellent. I'll go to the second router and configure all ports. Config here and on. This is GI000. Let us see here is /26. So I need to give the address 192.168.20.1, and the subnet mask is going to be 192. Good. And I still need to configure the serial 011 and 200.0.0.2, and the subnet mask is going to be 252. I believe it's operational now, and let's make sure the IP of the device 192.168.20.2, and the subnet mask is 192, default gateway 192.168.20.1. So it's running fine now. As you know, let us give names as usual. For this one, I say network A, and this one will be network B. So network A cannot communicate with network B. You either need to configure a default static route between the 2 servers, but this time we'll study Eigrp. Eigrp is a dynamic routing protocol, and it's very simple. You just go to each router, enable Eigrp, and tell it what networks the router needs to broadcast to neighbors. So, for example, router 0 needs to broadcast network A and the 1. Router 1 needs to broadcast network B and the 1. I'll go to router 0 and show you how to configure it. conft router Eigrp, and then a number. This number can be any number between 1 and 65, but must be unique across the topology. All the router must use the same number. It's like they are members of this group number. This is Eigrp 20. So now I starting configuring Eigrp 20. Now we need to pay attention to the subnet mask. It's done in a reverse way here, wildcard they call it. For example, network A, how to add it to the router? Network 192.168.10.0. Now for the subnet mask, usually the subnet mask is 255.255.128. But for router GIB, they take the wildcard, which is 0.0.0.127. It's the opposite. It's like if it's 255, here's going to be 0. And if it's 128, here's going to be 127. So the total of this with the subnet mask will be 255. So now Network 192.168.10.0 will be added. Also, I need to add the WAN network 200.0.0.0. What's the subnet mask of the WAN? 252, 252, 252, 255, 255, 255, 252. So it's going to be 0, 0, 0, 3. I'm done, by the way, with router 0. If you want, show IP route, and you will see that you have a network D here. And how many networks D? D. So what is D? D is Eigrp. So I don't have any static routes here. I have two dynamic. So how this is going to work? Let us first configure the second one with the two LANs or two networks. So let us just do exit. Router Eigrp must be 20, exactly the same number I used there. So what are the two networks here? Network 192.168.20.0, and this is 192, and 192 should be 0, 0, 0, and 192 should be 63 to make it 255. And let me add the WAN also, network 200.0.0.0. The subnet mask is 255, 255, 255, 252, and the wildcard mask is going to be 03. That's it. So when you see this, neighbor, adjacency, and adjacency means neighbors. So by the way, now, both routers and both LANs and both sides can communicate. I want you to see something before we test it. I'll go to simulation, I'll show none, and then I will show only Eigrp. This is critical in understanding dynamic routing protocols. Run. Look here now. The two routers are actually exchanging their routing tables. Router 0 is telling router 1 about its routing table. Router 1 is telling router 0 about its routing table. And they both know, for example, router 0 now knows network B, and router 1 knows network E. So see, the Eigrp packets are being exchanged like every interval. Okay, there is a time for each type of protocols, and there are so many routing protocols. So now I'll go to real time and try to ping. I will ping from this device. I'll ping the device on the other side. So let us just do 22. Let's do the ping now. If it pings, it means the dynamic routing protocol is working fine, and that's what you see. So again, we configured each router, Eigrp 20. 20 is just a group number. And then network A and network WAN, router 1, network A and B and network WAN, and that's it. And now they are exchanging their routing tables. Next, the question says how to configure also static routes. But how come we need both of them? The question says configure static routes only if the Eigrp fails. In routing protocols, there is something called administrative distance. Administrative distance is how trustworthy the route is. If the administrative distance is 10 for one route and for another is 20, the router would prefer 10. So what we're going to do in this case, the default administrative distance for Eigrp is 90. And for static routes is 1. So if there is a static route, the router would usually prefer static route. However, we're going to do static route, but we give it a very high administrative distance. So if the administrative distance of the static route is higher than that of the Eigrp, then the static route would be used as a backup secondary route only, and it will be activated only if the first route, which is Eigrp in this case, fails. So I believe you know static routes, so I'll go here and config here. If I try to make static route, I don't see here a point where I can, or a space where I can add administrative distance. So I'll use the command line. So I will go to router 0. I will tell it about network B. So IP route, we know this. Network 192.168.20.255.255.255.192. And this is the network, the subnet mask, and where to send it. I will send it to 200.0.0.2, which is the directly connected router of network B. And now is the new thing. 150. This is going to be the administrative distance of this route. It's the highest possible administrative distance. So high administrative distance means this is not going to be used if there is any other route with a lower administrative distance, and which is available because I know, and you know now, that Eigrp administrative distance is by default is going to be 90. Press enter. So I gave it this route. I go to the other router, repeat almost the same thing here. Exit. IP route. I'll tell it about network A, which is 192.168.10.10.0.255.255.255.128, and 200.0.0.1 is the next hub. 150 is the administrative distance. So now, if I go to our routing protocol, either of them, and show IP route, okay, I see here the static route, but administrative distance is what? 150, while the Eigrp is 90. So which one is going to be used? The 90. I see also, let us see this one, another one here. So the Eigrp administrative distance is 90, and this is the one that's going to be used. So I'll close this now. If for whatever reason Eigrp is not operational, then the router starts using the backup static route. And it's all about playing with the administrative distance of the static route and make it higher than that of the Eigrp.